Okay, we're continuing to talk about how vehicles depreciate, but instead of straight line depreciation, which is what you learned about in assignment 39, we're going to talk about exponential appreciation because vehicles don't always depreciate by the same amount every single year. To be honest, most vehicles depreciate exponentially, which means that they don't depreciate as much at the beginning as they do toward the end. But there is a formula for depreciation, and if you guys, you may have seen this before in one of your other math classes. The formula for exponential depreciation is y equals a times 1 minus r to the x power, where a, that's the starting value of the car. R, of course, is the percent depreciation expressed as a decimal. X is the elapsed time in years, and Y is the car value after that many years, X number of years. So let's look at an example. The book really didn't give us a good example of a problem like this, so I made this up. So let's suppose Bob buys a car that's valued at $40,000. It decreases in value by 7.75% exponentially each year. If I wanted to write the depreciation formula for that, remember it's y equals a times 1 minus r to the x power, where I'm just going to fill in what I do know. And I know that the beginning amount was 40,000, which is a. And the rate is 7.75%. So as a decimal, that would be 0.0775. And all of that is to the x power. So what the x and y stand for, the x is the number of years. So if I want to see what the value of this vehicle is after 5 years, I would just plug a 5 in here for x and simplify all of that to get my ending value. That's what y stands for, is your ending value. Matter of fact, let's do that. What if I wanted to see the value after 5 years? Well, y is equal to 40,000 times 1 minus 0.0775, all to the 5th power. So let your calculator do the work here. So I'm going to subtract these two first because they're in parentheses. So 1 minus 0.0775 is 0.9225. And now I have to do the exponent. So I'm going to raise that to the 5th power, and then I'm going to multiply times 40,000. So to the 5th power, I hit the y to the x button, and I get this decimal 0.66808. And now I'm going to multiply that times 40,000 without taking that number out of my calculator. So there it is. The value after 5 years would be 26,723.41. So that's how you can see, if you know the rate that it depreciates at, you can find the value after X number of years. So let's look at this example here. Eamon purchased a 4-year-old car for $16,400. It was 4 years old, and it was sold. He purchased it for $16,400. When the car was new, it was worth $23,000. Now this one's asking us to find the depreciation rate, the R number. So what we're going to do is we're going to fill in what we do know. So here's the formula: y equals a times 1 minus r to the x power. So the numbers that I do know is, I do know the value now, that's the y, the value after 4 years, the initial value, 23,000. The x number is 4. It was a 4-year-old car. So these are the three numbers that I know. What it's asking me to find is the r number. So I'm going to fill in what I do know. The value now, 16,400, equals the initial value, 23,000, times 1 minus r to the 4th power. So then solving this, I am not going to distribute this 23,000. I'm going to get rid of the 23,000. This is going to be an important step for you to remember. By dividing, this says 23,000 times all this. I can get rid of that by dividing by 23,000. So now I have this over here, and these 23s cancel out, and I'm left with this. Now, in order to get this exponent gone, Okay, very careful. This is a tricky step here. I'm going to raise this to the 1/4 power. So remember, when you raise a power to a power, you multiply the exponents. So 1 to the 1/4 power. This 1 minus r, this whole thing is to the 4th power. So I'm raising that to the 1/4 power. And remember, when you raise a power to a power, you multiply the exponents. And 4 times 1/4 is just 1. So it gets rid of everything except for the 1 minus r. So, but if you raise this to the 1/4 power, then you got to do the other side to the 1/4 power as well. So I'm left with this right here. And here I can let my calculator do the work. Take away 1 from both sides. This is what they did. And now you just have to simplify this expression. If you look at this, took away the 1, and they divided by -1 to get rid of that. So actually, we need to simplify this whole big expression here. So the order that we're going to do this in is we're going to divide this first, and then we're going to raise that to the 1/4 power. Your calculator will do that. You know how to do fractions on here. Okay. Then you're going to take away 1 from that, whatever number we get there, and then divide by -1. So this is a process. So I'm going to divide that first. So 16,400 divided by 23,000 is equal to this decimal. Now I'm going to raise that to the 1/4 power. So that's this y to the x, and then the fraction 1/4. Now all of this is equal to what's in my calculator now. Now I'm going to take away 1. That's that part. And now I'm going to divide by -1, which leaves me with 0.081077, and I'm looking for the rate. So remember, I have to move the decimal back. So the answer is going to be 8.1% when I move the decimal 2 places. Okay, let's look at another problem where you're given different information and you're asked to find something else. A car exponentially depreciates at a rate of 6% per year. Beth purchased a 5-year-old car for $18,000. What was the original price? So X would be 5. That's the time. The rate is 6%. She purchased a 5-year-old car for $18,000. So that's the value now. We want to know what the value was when it was new. So that's the missing number. So we're going to plug in everything we know. And working through this, you can go ahead and simplify the parentheses. 1 minus 0.06 is 0.94 to the 5th power. And then the way they did this, they just divided both sides by 0.94 to the 5th power to get A by itself. And then whatever this ends up being, that's how we're going to get to this answer. So you have to do the 0.94. If you're on this kind of calculator, 0.94 to the 5th power first, which gives you 0.733904022. So 18,000 divided by that. I didn't use the whole decimal, so mine's going to be just a few cents off, but 24,525.16 is what I got. They got 24,526. So around 24,500, give or take. All right, moving on. Actually, we're not moving on. That's the end of the lesson.